Welcome back to the Typhoon Legacy channel. This is episode 8 and I'm going to update everybody on exactly what's been going on with the systems installation on our Rolls-Royce Merlin III engine. You might have seen some of our images or video clips that have shown updates that haven't been discussed, and today I'm going to cover all of them. One of them being the control panel itself is nearing completion. It's still got its protective plastic on it just because we don't want any scratches, but we've outfitted it with our gauges and buttons, and you'll even notice that Rob has been busy wiring away. So just a few more connections to do in here, but our gauges are all set up, most of our buttons are set up, and you'll see this little guy here. This is our booster coil, or the shower of sparks that you might have heard Rob refer to. And it's a new old stock booster coil. It's 12 volts, and Rob took it for a trial run, and the sound is absolutely awesome. So we know that works. It's mounted in the box here now, and it's wired into the whole system. So when you press the shower sparks button, it's just going to throw sparks at all the plugs it can, and hopefully we'll get things to catch. You'll also notice that there's a black box in the case, and this is one of Rob's ideas. It's a 24 volt charger, and we decided not to put a generator on the engine because it's not really going to run very long, but we still needed a way to keep the batteries charged and ready to go should the engine be used. So this charger is mounted face down. It's open on the bottom, and it just plugs into a normal wall outlet, and it'll keep the batteries fresh and ready to go for the next time the engine's used. You'll also notice that the magnetos are installed, and you'll probably also remember that Rob did a huge amount of work to make 2 functional magnetos out of 4 or 5 of them. Well, the work didn't stop there. To be able to mount them, the magnetos need to be timed, and I was fortunate to convince Rob to get on camera and show us exactly what it took to time these.
All right, fellas, just doing a pre-operation here on the magneto to actually get it timed to the proper spark plug for the V-bank. So what we've done is we've locked the magneto advanced, so it's full advanced now at 50 degrees with the Cleco pin down on the side. So what you do is they put this little, I've got a little, it's actually a motorcycle tester for doing ignition on motorcycles. So it's across the 2 points. And this thing here, if the contacts are closed, there's no noise. If the contacts are open, then it makes a noise sort of thing. I'll show you what it does here. Yeah, you can hear it squeal. So that's how close the tolerance is in. I can make it squeal just by moving the magneto about maybe 5 thou. So what you want it to do is just have a light squeal on it, which it's doing right now, if you can hear it. So then what I've done now is I've locked the distributor rotor here with this gear and this clamp I made up so I could lock the distributor rotor at the proper point. Now this is the pin that fires to the cylinder. When this is on in that spot, because this rotor is on the outside, it's sitting right underneath that B1 where it's supposed to be there. So it's all locked down now, so it's ready to be put into the engine. And I'll turn this off and show you the back side. So this is the actual quill drive that goes into the engine, and that's how it drives. If it doesn't line up when it goes in, then you just take this off and move it one spot and put it back on. So that's how you just keep doing that until it actually goes into the spline and drives comes up properly. So that's what we're going to do now is figure out how many turns we have to do to get that to fit on the proper way. It's going to be, that's what, 6 moves so far?
Thereabouts, yeah.
Come on. tricky.
That's it.
She went in, boys, so she's timed now.
Awesome.
That was, what did we move it, 7 times that time? The other one we did it at 4, but yeah, so that took 7 tries, but now it's fully engaged. All that has to be done is bolt it down before I can let the clamp off here. And it was put in at full advance, so the magneto is recharged there full advance that way because the thing is turning that way. So there, that's basically it. Just clamp it down now and I can put the caps back on, and then we can start bringing the ignition wires down and put them into the caps.
Like any other project of this size, the last 10% of the work is really very time consuming, and that's because it's ironing out all the little details as they start to come together. So the Merlin's not letting us down in that regard, and if you look back to Season 2, Episode 4, I ran you through some of the issues that we had with the magneto side plug wire ends. And we've come to the point in the build where we actually have to install those. So there's still a little bit of a modification that I need to do to our new ends to allow us to connect them to our magnetos. So that's what I'll be showing you now. So today I need to impart a modification onto our Lancaster plug wire ends to make them more like our Hurricane, Spitfire, Fairy Battle, Merlin III plug ends here. So you can see that between the two, this is the original one that came off our BTH mags, and it's quite a difference in overall length, as well as the diameter of this shoulder here is quite a bit smaller, and the overall length of the back portion here is quite a bit shorter. So the first thing I'm going to do is take them to the lathe and essentially do this. Take it from this unmolested version here to a reduced diameter lip and reduce the overall length of that back portion there. The first thing Rob and I did was we took our plug leads and we ran them from the spark plug to the correct magneto. Now, for those of you that are not familiar with aircraft engines, there are 2 spark plugs per cylinder, and in the case of the Merlin, one is on the intake side or the lifter valley side of the cylinder head, and the other one is on the exhaust side or the outside of the cylinder head. And these go to different magnetos so that one fires just slightly in advance of the other one. So what we did is we ran these to the correct magneto. All the lifter valley ones came off to the right hand side of the engine if you're looking forwards, and that is our intake side magneto, and all of the exterior ones ran all the way around to the port side of the engine or the left side of the engine as you're looking forwards, and that is our exhaust magneto. So with those now lined up and in the correct position, we were able to build in a little bit of slack so that we could tie them off properly. Everything was labeled correctly and documented for length. We marked out with our plug lead, the caps, the magneto caps here, we marked out exactly the length that was required and removed it all from the engine so that we could begin completion of the wiring harness on the bench without the complication of jumping over the engine. So you can see here, this is our exhaust side harness, complete, intact, and ready for installation. What I'm working on right now is the intake side harness, and this is the one that runs down the lifter valley and across to the starboard side magneto. And you can see that I've got caps here, all installed and good to go, and now we just need to trim these guys down and install our magneto, our little Bakelite magneto pieces. So I'm going to show you the process for that today. So I can't stress enough how long this took us. It entailed what you can see a bit of a schematic here in blurred vision, and that was me drawing these caps, taking measurements internally and figuring out exactly how long we needed to trim back the plug lead to install it correctly in this cap. So what that entails is a fairly crude measurement of roughly 1.25 inches marking on each one of the plug leads, and that's for our shielding removal. And I'm just going to do this with one random one. They all need doing. And I like to give it a little twist just to break any little bits of that shielding that are holding on. I've got a little bit of just dish soap, and dish soap is going to go on here. So now this guy will go on here and I'll feed that wire through the hole. There we go. And that'll give us a measurement of approximately 2 1/4 overall. Looks good. We take our little hat section, that's the first of 2. Slide that down, boop, like that. And I take my side cutters, trim that out of there. Now we've got to take all of those little stainless wires from the ignition lead and spread them out as uniformly around the circumference of that little hat section as possible. So once you get them over flat, then I take them over even farther, and they have to wrap around the end of that little hat section. So we took an inside measurement of the second hat section and determined that it's approximately 5/30 seconds. So we found well, Rob found this little brass tube that he had, and it has the correct inside diameter, and I just push it over those wires to seat them properly. And that'll ensure that our second hat section goes on without too much of an issue. So here is hat section number 2. Same thing, it goes down with the big end down. Stick that in there, and I use that tube again just to press it down. I want to make sure it's seated really well, just like that. And we have to install a spring, and that one actually, it fits fairly snugly over that second hat section, and it seats on the hat, if you will. You can see on the end of the caps that there's a little bit of a shoulder, and that's the reason that we weren't able to shorten these anymore and are going to be building an adapter plate to go in here. But that shoulder seats inside this Bakelite cap and locks it in place, so it allows it to, or it prevents it from coming out. So it's got 4 little legs on it, and I compress 2, fit it over top, push it down, and just gently work it in until it goes inside all the way. There we go. You hear it click through, and now it's retained in there properly. So let's see if I can move that. Oh yeah. Boop, boop, boop. I'll start by changing over this one here. That's our coupling that'll be going to the engine oil intake. This one right here will stay the same, and that's actually our small adapter that'll be going to our oil priming pump. So we've got 2 outlets. This one will be changed, and then I'm going to go ahead and put the other return line just up at the top of the tank here, so the return will go into the top, drop down, and we'll be able to scavenge as much oil as possible from the bottom with this handy dandy shape here. This is a 2-inch coupling with a 1/4 inch wall. So I've marked out where I want the outside to sit, which is getting pretty close to the edges, but it'll weld in there nice and get as much oil as we can get out of this tank. Put the female die on top, and I've lubricated the threads on this bolt. I'm not too sure if you can see that. There's a lot of force on these, so there we go. It'll help everything go together without too much of an issue, I hope. Voila! So I'm going to go ahead and I'll take it over to the lathe, I'll part it off in the middle and prep the edge, and that one will be just about ready for welding. Just see, that's wonderful. So there's our tank outlet that will be running to the inlet on the Merlin. Now next I need to put another one right here, and that's the return. This one drops in a little nicer, and we'll do the cleanup for welding and get this stuck together. As you can see, we've got the oil tank installed now. It's full. The system's been pressure checked and everything's been primed up. Here is the modification that we did for the main line that goes out to the Merlin's oil pump. And here's the modification that we did for the return line coming out of the oil cooler. You'll also see the connection's been made for our oil priming pump. We're still working on a bit of the wiring, but the oil system is now complete. I didn't show any process on our coolant tank because it was essentially the same as the oil tank. But here it is. It is a off-the-shelf hot rod fuel tank that we modified with a couple fittings for the water or the coolant to flow out of the engine into the tank. And then we also drilled a hole and mounted a thermostat housing for the water to come out and then over to the radiator. And on the opposite side, we've welded a spigot fitted with the coolant temperature and pressure gauge directly in front of the engine operator. Another area that a substantial amount of work has gone into for this engine is the throttle linkage itself. Now this is essentially like the differential on a car. It's got a bunch of gears in it and a whole bunch of internal and external stops that control where the throttle, the mixture control, the primer pump, and the magneto advance are. This took quite a bit of time and Rob was able to figure it out. We weren't privy to having too much information on it or being able to find too much experience on the early linkages. So it took quite a bit of investigative work, but we definitely had the right man for the job there. Like I say, it did take quite a bit of time, but we've got it all dialed in now. And it's functioning with our advance and retard of the magnetos, our priming pump, which is, I don't know if you can see that, this one here. It's a big boost of fuel that goes in there, and our throttle linkage, which is this one. So it's working stop to stop there. And then we've also got this one here. This arm is the mixture control. So that one is functioning and it adjusts from rich to the lean position. In addition to the factory linkage that's on the back of the supercharger, we needed to develop our own linkage system to connect the throttle lever and the mixture control into the factory setup. So basically what we did was we created a two-shaft system, one that runs internally through the other, and that allows us to control both independently without having too much of a bulky complex system built onto the back of the control panel itself. We used a series of rods with ball joints that are very similar to the Rolls-Royce ones, albeit a different size, to keep things simple and moving freely but without too much slack or adjustment requirement. It took a little while to dial all that in, but it works well now. We're working stop to stop without any weird little anomalies in it, so we can move on from there and go on to some other systems information. Perhaps one of the most advanced visual progress pieces that we have is the propeller itself, and this would not be possible without Western Propeller of Richmond, British Columbia, the Bomber Command Museum of Canada, and the fine folks over at KF Aerospace who helped us out with some very serious procedures done to the Spider to make sure it was safe. So thank you all very much for that. This propeller is not an easy situation for us to deal with. Neither Rob or I have any experience with props, and leaning on the guys that knew what to do was absolutely instrumental in making sure this dynamic component of this whole project is safe for operation. If you guys are watching this on YouTube, please consider heading over to our paid video channel. In Canada, it's $8.99 a month. It's billed out in your local currency, depending on whatever country you're on, and you get early access ad-free to all of our videos, as well as forums, giveaways, and early announcements and things like that. So please consider it if you can. It makes a world of difference to us.